Okay. So welcome everyone to our webinar on managing brown marmorated stink bug with biologicals. This is a specific focus for preventing pre-harvest fruit damage. Peter Jentsch, our guest speaker, is an entomologist from Cornell University and is associated with the Hudson Valley Laboratory. He'll be sharing his most recent research that was focused on apples. However, this research can be applied to all palm fruit, as well as a lot of specialty vegetables, such as tomatoes and peppers. Our second guest is Dr. Timothy Johnson, and he is a biological expert with us at Marrone Bioinnovations. Before I go into detailed introductions of our guest speakers, I wanted to let you all know that this webinar is being recorded, and you can use, and you're all muted. So if you have any technical concerns or you can't hear our speakers, please use the chat function at the bottom of your screen to communicate with us. I'll be watching that throughout the webinar and will do my best to assist you. If you have questions throughout the webinar, please use the Q&A box, which is a different function on Zoom. So the Q&A box is great for posting your questions, which we will be monitoring and we will make sure to answer at the end of the webinar. Okay, this webinar will be going for about an hour. If you have to hop off, I will be sharing the recording and a copy of the presentation in a follow-up email. So not to worry if you miss something or you want to review anything. I'm just going to go back to our chat box really quick. I was asking people as they signed in if you feel comfortable sharing where you're coming from or where you're tuning in from, I guess. We always love to see where our audience is coming from. I'm going to go ahead. So we have another North Carolina, Western Massachusetts, Florida, Michigan. So we're so happy you're joining us today, and feel free to use that chat function to share with everyone or just the panelists. I'll go ahead and get started. I'd like to introduce our speakers. So our first speaker is Peter Jentsch, and he is a Senior Extension Associate and Superintendent with Cornell University and the Hudson Valley Laboratory. He has a master's in entomology from the University of Nebraska-Lincoln, and his focus is in apples, pears, grapes, and vegetables. His research has been focused on efforts on the monitoring and management of newly invasive agriculture insect pests, advances of newly developed pest management tools, application timing of insecticides with unique modes of action, and reduced risk alternative technologies such as mating disruption, organic insect pest management, and biological control conservation. So Peter, thank you so much for joining us for this webinar and sharing with us your most recent research. We're really excited to learn more about it.
My pleasure. Looking forward to it.
Our next speaker is Dr. Timothy Johnson. He's the Vice President of Product Development and Technical Services, or Sales, excuse me, with Marrone Bioinnovations. He has a Bachelor of Science and a Master of Science from Iowa State University in entomology, and his PhD is from Purdue University. Tim has over 34 years of experience in the development of biopesticides, including microbial insecticides, miticides, nematicides, microbial and plant extract fungicides, and pheromones for insect monitoring and mating disruption. For the past 10 years, Dr. Johnson has been responsible for developing efficacy data worldwide at Marrone Bioinnovations. He's a published researcher and lecturer and holds 6 patents. So Dr. Johnson, thank you again for being on one of our webinars. We always appreciate the wealth of knowledge you bring.
Pleasure is mine.
And with that, I'll just go ahead, and I need to inform you that Marrone Bioinnovations is a publicly traded company. If you have any interest in investing in the company, purchasing stock, we just encourage you to do your own research. And then with that, I'd like to hand it over to Dr. Timothy Johnson, who will give an introduction of Marrone Bio and a product overview. So Tim, I'm going to go ahead and transfer the controls now.
A little bit of a time lag here. Waiting for the. Oops. Well, thank you, Angela, and thank everybody for joining us here today. I think we have a very timely topic to talk about management of brown come up to the upcoming fruit season. Our agenda today is we're going to talk a little bit about a brief introduction to Marrone Bioinnovations. There may be three or four people yet on planet Earth who are not familiar with us, probably, of course, a lot more than that. We'll give a little bit of an introduction to the product that we're going to be discussing today, which is Venerate XC. What's going on? Having some issues getting control of the screen, Angela. Then we'll talk about managing brown marmorated stink bug with Peter Jentsch. And then we'll finish up with some recommendations and take some questions and answers at the very end. So if you're not familiar with the company, as Angela mentioned, we are a publicly traded company on the NASDAQ exchange. We had our IPO in 2013, but the company was founded in 2006 by Dr. Pam Marrone, who is an entomologist via Cornell and North Carolina State University. We're headquartered in Davis, California, with a manufacturing plant in Southwest Michigan and Bangor, Michigan. We have nationwide sales and technical support folks that we'll talk a little bit about at the very end of the presentation. We are predominantly a U.S. company, but we do have sales in other North American countries such as Canada, Mexico, and are expanding in a number of other countries worldwide. Dr. Marrone recently retired as our CEO. She remains on our board of directors, and we have a new CEO, Mr. Kevin Helash, who joined us at the beginning of August. We are predominantly a biopesticide company with a kind of a focus on microorganisms, but that's not our only technology. We also have a bionutrition technology through a recent acquisition with a company called ProFarm in Finland. That's a very nice complement to what we do with biopesticides. But we are probably the only pure play biopesticide market that's publicly traded. Next slide. Briefly just mention our products. In the 14 years we've been in existence, we have developed internally and with a little bit of acquisition, a pretty complete portfolio, a lot of different segments of agriculture. We have 2 fungicides, Regalia, which is an ISR, SAR type product. Stargus is a bacillus-based fungicide. 2 insecticides that are microbial and metabolite based, Grandivo and Venerate. Jet Ag and Jet Oxide that are peroxyacetic acid based. And then 2 plant nutrition products, Pace Setter and Haven, with very different modes of action. Next slide. But our focus today, at least as far as Marrone Bioinnovations is concerned, is a product called Venerate XC. So if you look at the label, it will say heat-killed or non-viable Burkholderia rhinogessus, strain A396. This is a very unique strain of Burkholderia that was discovered in our internal screening program. We saw very early that it had some very interesting insecticidal activity. So we've had the product in the market for about 4 years now, but what it contains are non-viable cells and biologically active metabolites that are produced during the fermentation process. So it's a metabolite-based product, has excellent shelf life because of that, but it's also an OMRI-listed product. So as you would expect with an OMRI-type product, we have a 4-hour reentry interval, and very key to the conversation today, we have a 0 days to harvest pre-harvest interval. Product is low risk to pollinators and beneficials. We'll talk a little bit about some specific recommendations towards the end in terms of surfactants and so forth, and when we talk about some specific recommendations. Mode of action wise, it depends a little bit on the target pest. Venerate is broadly active against quite a few sucking pests, some mite species and some Lepidoptera. We see exoskeleton degradation when we have the exposure through contact against various adults and nymphs. We also see activity through interference with molting as insects molt from one stage to another, especially with immature true bugs and such. And then for chewing insects, such as certain beetles and Lepidoptera, we see toxicity through ingestion that is somewhat almost reminiscent of a BT insecticide. What's very important though, especially for sucking pests, and again, very relevant to today's discussion, is that Venerate has the impact of stopping feeding very rapidly, and that cessation of feeding can be fairly long lasting. It's important to note that the activity is fairly slow when it comes to mortality, but again, that feeding cessation is very rapid. Next slide. I'm going to talk about a couple of pieces of data that sort of preceded Peter's work, kind of gave us a little bit of a hint of what maybe Venerate was capable of in the early days. So we're going to be talking today about brown marmorated stink bug. And for about 30 years, I lived in northeastern Pennsylvania, which is where this pest sort of originated from as an accidental introduction. It was around for a number of years. Nobody was maybe as concerned about it as we should have been. And then in 2010, 2011, the numbers just exploded. So Tracy Lusky at the USDA ARS started screening a number of different products through exposure type assays. And this is just an example with sort of an early version of Venerate, what we called MBI-206, where a glass arena, a Petri dish was treated, it was allowed to dry, and then overwintering adults, which were physiologically a little bit different than our summer adults, were introduced to the arena, and mortality was noted over 7 days. And as you can see, it's pretty slow for anything to happen. We saw some more abundant activity, that's in the yellow and the orange. The red is mortality, but then as you get into days 4, 5, and 6, you do start to see some substantial mortality. The next slide is a field study with an early commercial version of Venerate. This is conducted by Dr. Ann Nielsen at Rutgers. And in this case, she was looking very specifically at preventing damage at the very short PHI before harvest on peaches. In this case, she's looking at Venerate, a single application compared to Danitol and the untreated check. And it's worth noting that we had a very significant, statistically significant and numerically substantial reduction in both of the percent damaged fruit and the number of stings per fruit. And that's kind of where we were after 2013. And then Peter, as he's going to explain in his research here in a minute, did some very interesting work that I hope that you'll find to be of great use. So with that, I'm going to turn it over to Peter and take it away.
Thank you, Tim. So I'm going to try to get control of the screen as I begin the conversation. In the Hudson Valley, as is in much of the Northeast, Michigan, we really have a complex of stink bugs. And so for many years prior to the introduction of brown marmorated stink bug, we did have brown stink bug and green stink bug to be concerned with. And as with that complex of insects, it seems like over the years, the drivers for the insects tend to be heat and drought. When you have high heat and drought conditions, very dry environmental conditions for them to reproduce, there's a number of things that occur and other things that don't occur. One of the things that typically don't happen as frequently is the entomophagous fungal pathogens or bacterial pathogens that the insects come in contact with and that succeed and tend to bring down the populations. Would be things like Microsporidia, and Nielsen at Cornell is doing quite a bit of work looking at that, as well as Bovaria bassiana. And both of those can really reduce populations of stink bugs generally, and for brown marmorated stink bug, a lot of emphasis now is being placed on these biologicals. And under those conditions where you have high relative humidity and sort of persistent rain, these pathogens tend to knock the population back. However, brown marmorated stink bug, since its incursion into the Hudson Valley in 2007 or 8, we had some samples come into our lab. We've just seen drought conditions fairly frequently over time, which really do lend themselves to very high populations. And so 2012 for us was a banner year, as it was throughout the Northeast, where all the stars lined up and it was almost a perfect storm for this insect. We saw quite a bit of injury at first on jalapeno pepper and tomato, and then later in the season on apples. And we typically see a rise in the population, likely from a second generation, depending on season, from brown marmorated stink bug, where the nymphs transition into adults sometime early in August, and the populations really begin to increase. So I'm going to try to take control of the screen here. I'm also having some difficulties with that. If you could advance the slide. Oh, here we go. Let's see if this works for me. So as we began to run into problems with stink bug really late in the season, we found that there were situations that tree fruit growers in particular had where they had mixed blocks. They were trying to harvest early Honeycrisp that were up against later varieties of Honeycrisp, and then moving through to Red Delicious and some of the other New York varieties like Ruby Frost and Snapdragon, and then ending with Pink Lady. They just could not make applications throughout the entire orchard in a timely fashion, or in a way that would keep the stink bugs out of the orchard. And so you could put an application on of a very efficacious insecticide like bifenthrin and get excellent mortality, but the reapplication interval of 30 days, and as good as the residual is, anywhere between 7 and 14 days of residual activity on some of these insecticides like bifenthrin, really don't buy you that last 7 days to harvest. So leverage is one of the few materials. Closure is another that allows you to apply the material on 7 days prior to harvest. But if we have rain events, you have other events where we have just an onslaught right up to harvest, that led us to think that, you know, this is an insect that's extremely difficult to control as it moves in during that harvest interval. So we began to look at Venerate because of the 0 days to harvest. And with work that was done by Tracy and by Ann Nielsen, there was some implications there that Venerate is effective at reducing the population and or reducing the amount of feeding that occurs on crops right up to harvest. So we began an investigation looking at both topical applications. So you see here on the left, we used these small plastic shot glasses in which we placed adult brown marmorated female and male onto green beans, placed 2 microliter application on the thorax just behind the head of the insect, and we then looked at both mortality in the lab and mortality of placing these insects in the field. The second part, or the comparison part of our study, was to look at untreated insects that were applied to fruit that had been treated using 300 psi on a pack tank sprayer, applied dilute on Red Delicious trees. So that's what this second image represents, which is a plastic shot glass in which the back end was removed and screened, and we would place these insects on the shaded part of the fruit so that the sunlight wouldn't directly hit the container, the arena, and bring about a high level of mortality, which we did see in some of our earlier studies. So by placing the insect on treated fruit, we would then encircle that feeding arena, the edge of the cup, with a Sharpie, and we can determine both mortality of the insect over time as well as feeding propensity, and to look at different levels of feeding injury. So with that, in 2018, this was sort of a follow-up from some of our early studies. We were looking at topical bioassays in which, as I mentioned, 2 microliter doses were placed on the thorax of the insect, and we used Li-700 as a surfactant with our insecticides, or we used the Li-700 alone as another check. And we were looking at surround to see if it would inhibit feeding. We looked at Tara, bifenthrin, closure, venerate, an untreated control. The surround also had a 1% oil component to it. And we looked at this in terms of doses at the highest labeled rate, and then half of that and half that again. So looking at 3 different rates over time. And we also looked at the moribund status of the insect as well as it being alive or dead with regards to a 24, 48 hour and 7-day post-treatment evaluation looking at those doses. In 2018, we found that we just had really high temperatures in the field and just could not get the data that we would like to have generated because of the high mortality of the insect. So this year we focused on our bioassays, and here are the rates. My apologies for the small print on this slide, but I'll get to the graphs in a moment. The graphs down below just represent mortality at the highest labeled rate. So a lot of this work had been done over time by a number of other researchers, and our findings using these topical applications, bifenthrin seems to be one of the best materials available for producing mortality of the insect. And so if you want to kill the insect, which is sort of the traditional mode of action of pest management, then the pyrethroids, bifenthrin in particular, tends to be quite good. Actara, with regards to the neonicotinoid group, is also very effective. Closure, I believe that's sulfoxaflor, is also an anti-feedant. We wanted to compare that to Venerate, and you can see across the remaining materials, including surround, the Li-700 alone, very low levels of mortality within the first 24 hours. As we move forward to 48 hours, very similar results, a little better mortality with Actara. Closure starts to provide higher levels of mortality, as does Venerate. And as we move into the 72 hours, there we go, I'm sorry, 7 days, we found additional mortality in the Actara treatment and some additional mortality in Venerate, but closure really did then begin to show the mortality after that period of time, which was very encouraging. But again, what we're looking at with these insecticides is the pre-harvest interval. And so given the fact that closure has a 7 days to harvest, we're still trying to fill that gap from the time that you can put an insecticide on till the time you get the fruit off the tree. So we pursued this in a earlier study, looking again at bioassay topical applications, in which we were focusing on Actara, bifenthrin, closure, and Venerate, along with the untreated controls, looking at 4 different rates, with the highest dose being the highest labeled rate. And again, assessing them in terms of their mortality, or whether they were alive or moribund. And so these were again recorded at 24, 48, 72 hours and at 7-day intervals. And these micro applications with the use of Li-700 allows for that material to distribute over the insect. And so, we feel like with this type of approach really does give us something as close as we feel we can get to a field application of a direct contact to the insect. So as we moved into this study, we then also took the insect, placed them on untreated fruit on the 28th of September to see what level of mortality they would experience in the field. We had 1 insect per fruit, 2 fruit per tree over 5 trees and 10 replicates. These were then removed after 7 days. The fruit was collected on the 12th of October. So what we wanted to do is to be sure that if the insect fed on the fruit, as the fruit was on the tree maturing, that it would express the feeding injury. Oftentimes, one of the issues that growers have, and what makes this insect really unpredictable and difficult to assess with regards to the use of traditional integrated pest management, is you may see the insect on the tree, you may even see it feeding, but you might not see the expression of the feeding, for a number of days, anywhere from 7 to 14 days. So as you could barely see here, if you will, on the arena, you can see the Sharpie circle drawn around the arena, and that allows us again in the lab to focus on different levels or expressions of feeding injury. So, boy, this is a busy slide, but basically, as we know with most insecticides, there's an inverse relationship between mortality and dose. So the stronger the dose, the more mortality we see in bifenthrin and Actara. As we move from 24 to 48, 72 hours to 7 days, you can see the purple being the moribund state. We described that when we made our evaluations, the moribund state being an insect that is flaccid, yet either on his back, not able to stand. So the legs are not stiffened when we assign that moribund state to that particular insect. An insect that is dead is stiff legs curled up toward the abdomen, and there's usually no recovery. However, many growers that have applied certain materials on the trees will see the insects rain down on the tree and then 3 days later come back and be quite active. And we do see some of that in some of these topical bioassay studies where with bifenthrin we see increased mortality, but sometimes in materials like Actara, for instance, after 7 days, we do see an increase in a moribund state and a decrease in what we would have observed from the what we would consider to be the dead state. What we're really after is this particular set of data over time where we took the insects, made topical applications, placed them on the tree, and then assessed the fruit. So if you look at the 4 insecticides that we have here in the left column, after 7 days, the number of feeding sites per fruit for all of these insecticides were numerically lower than the untreated controls, but given the variability in the field, we didn't see statistical differences after 7 days with regards to the number of stings on the fruit. Numerically, Actara, Venerate were lower, but nonetheless, and certainly lower than the untreated controls, but there was a lot of variability there. Dimpling on the fruit, didn't see much across the boards. Corking on the fruit, same sort of thing, even in the untreated controls, didn't see it. But when it came down to the clean fruit with regards to feeding injury, we saw that all of the treated fruit looked very clean compared to the untreated controls. The survival in the insect was surprising with regards to Venerate. Bifenthrin and Actara was to be expected, and closure also to be expected given the lab bioassays that we had. So how does that relate to our field applications? So when we placed the insects on treated fruit and we placed the arena around them at the corresponding rates, so at closure at the 5.75 fluid ounces, bifenthrin at 32 fluid ounces, Actara 5.5, and Venerate at the 128 fluid ounces per acre. These were applied with a handgun at 300 psi, so we felt we had really excellent coverage. And we had 3 different placements. The insects were put out 24 hours, 48 hours, and 72 hours after the applications were made. So the topical applications, the residual applications then are reflective of when the insects would have come into the orchard and landed on the fruit. The fruit was then collected, the insects were collected 7 days after placement, and the fruit was collected 14 days after. So the interesting thing about these arenas is we ended up having to put smaller holes on the arenas as well to reduce the amount of moisture that might accumulate in heavy rain events. The arenas could get flooded, but nonetheless, by being able to place them sort of at an angle so they can drain out was one of our challenges with this particular bioassay. So here on the fruit residue, we had some differences, again, in the number of feeding sites compared to the untreated controls. Dimpling for fruit, really didn't see much. Neither did we see in the corking after 7 days. After 24 hours. And the clean fruit did show numeric differences, and the survival level, again, in the Venerate looked relatively low. However, when we had the insects placed on the fruit after 48 hours, we began to see some differences. And what we found was that Closure, Actara, and Venerate did show additional feeding compared to bifenthrin, which had really high levels of mortality. Yet, when we look at it compared to the untreated controls, we did see statistical differences between these first 3 compounds. There was no difference between the Venerate and the 3 compounds, and Venerate was not different than the untreated controls. The dimpling on the fruit began to appear a little bit more in the untreated controls, and we did see additional corking on the fruit in the untreated compared to the treatments. And what was also quite interesting, and overall, the clean fruit, there was no statistical difference between those treatments, but there were differences between Closure, bifenthrin, Actara, compared to the untreated controls. And again, the survival for Venerate looked really high. So what happens after 72 hours? When we place the insects on after 72 hours with only residue on the fruit, we did see additional feeding across the boards, but Venerate actually looked a little bit lower numerically, not statistically, but compared to the untreated controls. And the dimpling on the fruit also, Venerate looked really quite strong compared to the other treatments. Again, not statistically different. The corking on the fruit, same thing. A lot of variability with some of the other treatments, but across the boards, Venerate did not show corking on the fruit. And with regards to clean fruit, we had, again, no statistical differences, but with the numerics in the field applications, we did see 90% clean fruit across all treatments compared to 40 in the untreated controls, with relatively high levels of survival, surprisingly, with Actara after that amount of time. So we were fairly encouraged with this data, given the fact that Venerate in the field, in both topically treated insects and in residual, did provide a level of feeding cessation that was really quite encouraging. We would like to be able to continue these trials given the right conditions. Those of you that try to rear brown marmorated stink bug know the challenges that exist. The microsporidia levels that can exist in a laboratory colony are quite impressive. At the lab during our overwintering evaluations of microsporidia, we had upwards to 60% levels of infestation. So with that, what I'd like to do is simply close by saying that more work needs to be done, but this mode of action of a material that can inhibit feeding over a 7-day period really does allow many growers an option that they would not have with pyrethroids, carbamates, organophosphates, or neonicotinoids. A material that would allow a grower to make an application. One, they'd certainly be able to sleep better at night, but most importantly, if we can inhibit the feeding and the damage, then I think we're in a really good place to be able to make recommendations on the use of these materials, such as the biologicals, to fill a gap that's really needed in both conventional and organic production systems. So with that, I'd like to turn it back over to Tim, and wait for questions as we come toward the end of the presentation. Thanks.
Tim, I'm sorry to interrupt. You're on mute. Tim?
Can you hear me, Angela?
Now we can, yes.
All right, sorry about that. Yeah, that's Zoom hell, we call it. Okay. Okay, so now that we got that straightened out. So I'm going to review a little bit about what Peter presented and talk about some specific recommendations for Venerate for this late season application to prevent damage from brown marmorated stink bug. Very important. First of all, obviously this has to be part of what has been a season-long management program for brown marmorated stink bug, because we were very focused on this window at the very end of the season when we're basically within 7 days of harvest and during harvest, because obviously harvest can take multiple days, you know, to be in the grove picking apples. So a couple of important things. Obviously coverage is extremely important, especially on the fruit. And we also need coverage that's durable. So when we're in the upper Midwest and the Northeast, we have to worry about rainfall events. We've done a fair amount of work looking at adjuvants and Venerate. And interestingly enough, if I were to pick one adjuvant that I would have recommended Peter not use, it would have been LI 700. It's a very good adjuvant for spreading, but it is a bit of an acidifier. And we know from laboratory work, since Peter's work, that it will actually reduce the potency of Venerate somewhat. So we want something that gives good coverage, but hopefully that is also durable. Certainly New Film P, which is an organic material, which of course can be used on conventional fruit as well, is a good spreader and sticker. And you want something that spreads, but not so good that you actually get an accumulation of the product, say, on the bottom of the fruit. You need that nice uniform coverage. The second point that's important, of course, is the rate right now with our technical information bulletin that I have on the screen, we're sticking at the 4 quarts per acre. We understand that that is not the most cost-effective application you might ever make, but we haven't had the time and the experience yet to see if lower rates will perform similarly to the 4 quart rate. So that's kind of what we're sticking with right now. I do want to mention that, of course, we also do see a potential to use this on stone fruit as well as on apples. For support in the field, this slide shows our sales folks. We have Evan Carlisle and Lois Hawkins out in the Pacific Northwest, John Driver in the upper Midwest, very experienced on apples. In the Northeast, Steve Bogash. In the Carolinas and the Southeast, Hal Blackmore. And then in California, we have Brian Guess down in the southern part of the state. And then in the Valley, Taylor Hoover, Alex Jackson, and Doug McDowell. For technical support at the product development team, which is the folks I work with, we have Marina Sardani in the Pacific Northwest. Steve Bogash also handles those duties in the Northeast with a little bit of help from myself. I reside in Southern Virginia, so I also help out in the Southeast. And then we have Brian Miller in the Midwest and Great Lakes area, and Dr. Melissa O'Neill out in California. So I hope that you find this information to be of use. We are there to help you get a clean harvest and answer any questions you might have. And so I think at this point, I'll turn it over to Angela. It will have the question and answer session.
Excellent. Thank you both, Peter and Dr. Johnson. I'm just going to go ahead and check the, we've got some chat here. I apologize. When we share screens like this, it's, okay, it was just about Tim being on mute. Okay, so let's go ahead. And if you have any questions for our speakers, please put them in the Q&A chat box down. It's usually at the bottom of your screen. We have one question right off the bat. It is, have you, and panelists, you should be able to see the Q&A chat box as well, okay? So I'll read the questions out loud just in case our attendees can't see them. And then I'll allow we'll let the panelists answer. Okay, from John Wise, it says, have you had the opportunity to demonstrate this anti-feedant fruit protection of Venerate in a standard field efficacy trial?
Hey, John. We have put it into trials in which we're looking at San Jose scale, and we ran trials later in the season. It does not seem that we can get brown marmorated stink bug to show up the same years that we're running these trials. So my answer to that is no, we have not been able to show that in efficacy studies. That frustration is what led us to use the caged arena concept. And if we were to continue in the future, that's likely the way that I would continue working with the material. And John, you probably know as well as any, when you set up a trial and you put all the energy and effort into that, and you have a year where when you run the trial, it just rains until you harvest the fruit in those years, it's just a little frustrating. So we've gone to this method to try to confirm whether or not the material works. And in order for us to really look at it more closely, looking at reduced rates is likely the way we're going to continue.
Excellent, thank you, Peter. Tim, do you have anything to add?
Yeah, I might add that one other crop where we've kind of looked at the anti-feedant properties of Venerate pretty closely is potatoes, and that's for a pest called potato psyllid that transmits a bacterial disease. So feeding is very important. And we have looked at electronic penetration graph work where you literally wire the insect and the plant, and you use electronic instrumentation to evaluate the feeding behavior of the insect. And we do see a very rapid cessation of feeding behavior when the insect comes onto a treated potato leaf and starts to probe. So we do see this on other crops.
Excellent. Our next question is from Trang, and it says, thanks, Peter, for the data. From the results, are you suggesting Venerate to be a pre-harvest material only? Which soft chemical materials that can be a good in-season material for IPM approach with bifenthrin? Peter, are you there? I wonder if Peter had to step away. If you're there, Peter, you're on mute. Oh, there we go. Okay.
I'm just having mouse issues.
Oh, fun.
So the most difficult thing about brown marmorated stink bug control in my mind, and when I look at images of stink bugs generally and specifically brown marmorated, they tend to, and I'll also get a little more theatrical maybe by having my video on. You have the fruit, and then you have the insect with its tarses on the fruit and its proboscis down, which is sheathed, and then penetrating the skin of the fruit and then begin feeding. So it's on very, very little surface area with regards to its activity on the fruit. It doesn't lay its abdomen down or rub against the fruit in any way, shape, or form that I can see. Even when it's on the foliage, it's up high. So it gets very little exposure to the residual. You're rarely going to hit it with a sprayer. Usually as the sprayer is approaching the trees, the insects are moving and getting around the backside of the fruit once the spray hits. I mean, they're extremely adept at survival. The other thing about brown marmorated and pentatomid stink bugs generally is that they're the Hummer of the insect world. These are big insects, and so it takes a high dose of an insect to produce mortality unless it's an extremely effective insecticide. So if you look at the neonics, the pyrethroids, and the premixes that combine the neonics and the pyrethroids together, that's what it really takes to take these insects down. So you're looking at high rates of Actara. There's a material called clothianidin or belay. We don't have that in New York. In New England, I believe it's available. That would be a good choice as a neonic. But when you look at combinations like lambda-cyhalothrin, pyrethroid, and thiomethoxam, which you find in indigo, that's really what it takes to produce 90, 100% mortality levels in these studies. There's lots of materials that we would think would work, but they're really not that effective. So, we've looked at a lot of other materials. They just don't have what it takes to take this insect down or to keep it from feeding, really. And that's one of the exciting things about closure at 7 days to harvest and venerate right up to harvest. The rotation of bifenthrin and other materials like Actara, you only get really a couple of applications of Actara. The constraints, the labeling constraints on the materials are also problematic, and days to harvest to these. It makes it difficult to come up with a program, but if you send me an email, we can work on something that suits your production practice.
Excellent. Thank you, Peter. Okay, so our next question is from Sebastian. It says, hi, do you have any research experience in extensive row crops such as soybean?
No, it's an easy answer. I do not. I have looked at jalapeno pepper and tomato using things like Beauveria bassiana and unless it's really high relative humidity and high moisture, we just don't see the efficacy of these biologicals. The environmental conditions have to be perfect. So that's my only comment.
Yeah, Angela, I might also add that we've not really looked at soybeans, mostly just because of the economics. As we work on our next generation replacement for Venerate, which has quite a bit different level of the important metabolites, if you will, those economics might change and we might be able to revisit that.
Excellent.
Soybeans should be only susceptible for a relatively short period of time before they harden off and mature.
Great, thank you. Our next question is from Diane, and she says, since Venerate cannot be used in Massachusetts for hemp, can you recommend what may be used?
Yeah, I texted Steve Bogash, who's our Northeast rep, when I saw that question pop up to kind of get his recommendations. And our recommendation would be Grandivo plus either a soap type product, like one of the potassium salt or fatty acid products like Impede, or with azadirachtin, or maybe one of the Bavaria products until bud set, and then probably similar alternatives after bud set, except maybe taking out the azadirachtin. Because Grandivo should be allowed to be used.
Okay. Our next question is from Robert. He states, have you studied Venerate on brown marmorated stink bug on almond or pistachio in California?
You know, we have not. And of course, brown marmorated stink bug is a fairly recent introduction to California, and that is absolutely something we need to do.
Our next question is from Todd. Will this work on vine mealybug in table grapes?
Absolutely. It's a very good product. Just 1 or 2 quarts per acre, 3 to 4 applications per year for vine mealybug control. Yes.
And then from Scott, do not have stink bugs yet. Anti-feeding action against PC.
And PC means plum curculio, Angela. I can see the puzzled look there. Interestingly enough, PC was one of our very early targets with Venerate, and John Weiss, who had one of the questions earlier, has been a key collaborator for us. John Weiss is with Michigan State, working with us with both Venerate and Grandivo for plum curculio. And it kind of looks like right now our best combination is a tank mix of Grandivo plus about a half rate of Surround at 25 pounds per acre for plum curculio control.
Excellent. Our next question is from Greg. What happens to the brown marmorated stink bug? I'm getting tongue-tied now. After the 7-day protective period is over, harvest is completed for that variety. Since it doesn't die but stops feeding, does the BMSB live on just to attack the next crop, or does it just die due to the limitations of their natural life cycle?
Well, I guess I'll touch on this. It seems to me that over time, we do see higher levels of mortality from Venerate. There's other data to support from Tracy Lesky's work where the insect is constantly exposed to Venerate a high level of mortality. So it's likely that at least a portion of the population would die off, and the remainders may move off the crop and, you know, basically revive and start feeding on other host plants. That's my take.
Excellent. And the next question is kind of along the same lines from Scott. So does the marmorated stink bug recover from their stupor, or do they die after exposure? So
yeah, many of the moribund stink bugs do die off, but we have seen with pyrethroids, there's in many insects, different species that are exposed to pyrethroids generally will have a knockdown response. Cicadas are one of those insects, again, very large, robust insect. It will end up on the ground for 3 days, and during that period, ants, you know, whether they be carpenter ants or others, will begin feeding on them. But those that are left do then recover and and come back. So it depends on the material. Things like the neonicotinoids just may have longer period of time where the insect is moribund and then succumb, and then small portions of the population will revive and then go back to feeding. Depends on rate and the species of insect.
okay. Thank you, Peter. And we're coming up to our last question. So if there are any other questions out there, please put them in the Q&A box now. Otherwise, we'll wrap up with our last question, okay? From Jeff, any data on applications made to apples, conventional or organic?
Yeah, I'll handle that. Yeah,
Okay.
Jeff. Obviously, we've done a lot of trial work on apples over the years, both in the Pacific Northwest and especially in the central part of the U.S. at Michigan State, as well as working with folks at Penn State. I'm not exactly sure what you mean by your question about data from applications made to apples. Focus has typically been aphids, rosy apple aphid and woolly apple aphid. Say first generation cobbling moth, some of the leaf roller species, and then the work that Peter's doing. Also looked at apple maggot, but that's not a pest in the P&W. Question about tank mixing with essential oils. I don't recall any work we've done with that, and I'll check with Marina to see if I'm mistaken, but I would expect positive benefits because when we combine Venerate with conventional crop oils, very nice result. Taking a specific example last year where we had an organic almond grower had a very high population of two-spotted spider mites. Tank mix of Venerate and 1% crop oil, and it really did a very nice job with one application.
Excellent. Thanks so much, Tim. That wraps it up for all of our questions. I'll just do some final housekeeping notes. If there are any final questions, please type them now. Otherwise, we will go ahead and wrap up. I just want to thank everyone for attending the webinar, in particular our speakers, Peter and Tim. Thank you so much for sharing your expertise. For those of you that are interested, there will be a recording and a copy of the presentation sent out a few days after the webinar that you're welcome to share. And of course, if you have any additional questions, I'll just go back to, you can visit our website, marronebio.com, and we have more information about our products. And also you can find Tim's information if you'd like to contact Tim. And then for Peter, he's shared a couple additional resources here, his blog, as well as a specific website to gather some more information. So with that, I just have one little thing from the chat. I'll double check it before we wrap up. Okay, just thank yous. So with that, thank you so much for joining us for our webinar. And of course, if you have any questions, you can contact me or reach out to these resources here. Thanks and have a great day. Bye, everyone.
Thank you, Angela.
Thanks, Peter. Talk to you all soon.